Hello students and viewers, welcome back again to Science Capsule, a perfect self-learning tool for school children. In today's video, we will be discussing about one of the most important topic under electricity, that is resistance. We have already learned what is resistance while learning Ohm's law. A detailed video has already been uploaded. If you have not watched that video, then you will find it in I button and I will also provide in the description. As far as resistance is concerned, it is offered by the conductor. When the electric charges flow in a circuit, each and every material, that is the conductor, restricts the flow of charge in the circuit. This is what we call it as resistance. And this resistance depends upon various factors. Materials to material, the resistance changes. So in this video, we will be seeing what are the various factors on which the resistance of a conductor depends. And also we will study what is resistor and the resistance of a system of resistors and how the resistors could be combined in different ways. So this video is going to be very useful. So watch till the end of this video. If not subscribe this channel and press bell icon so that you will receive notification whenever I upload a new video. So let us start today's session. So dear students, resistance is the restriction offered by the conductor when the electric charges flow in a circuit. And this resistance of a conductor depends upon various factors. Let us now discuss one by one what are the various factors on which resistance of a conductor depends. The first factor is the length. If the length of the conductor is increased, then the resistance will also increase. If the length of the conductor is decreased, then the resistance will be decreased. So we can say that R is directly proportional to length. This is the first factor. Now the second factor on which the resistance of a conductor depends is area of cross section. Now here, what is area of cross section? Now look at the screen. Here the marked position is the area of cross section. How it is related to the resistance? If the area of cross section is increased, then the resistance will decrease. If the area of cross section is decreased, then the resistance will increase. So here some sort of inverse relation we could see, right? So we can say that resistance of a conductor is inversely proportional to area of cross section. Let us understand in a different way. Suppose if we have two water pipes, one is having more area of cross section and another one is having less area of cross section. Suppose if 100 liter of water is allowed to pass through both the pipes, then in which pipe more water will flow? Exactly, the pipe with broader cross section, area of cross section, the water will flow. The quantity of water will be more in case of the pipe which has more area of cross section. In a similar way, if the area of cross section of a wire or a conductor is increased, then more current can flow through it. So it offers less resistance. So from this we can say that if the area of cross section is increased, then more current will flow. Ultimately less resistance will be offered by the conductor, right? So by combining these two, we will get R is directly proportional to length of the conductor and inversely proportional to area of cross section. Here between R and L by A there is a proportionality which indicates that R is not equal to L by A. In order to make them equal, the proportionality needs to be replaced with some constant. So upon replacing it, we will get R is equal to rho L by A. It is not P, it is the symbol of rho. Here rho is the resistivity. So upon rearranging this, we will get rho is equal to RA by L, and the SI unit of resistivity is ohm meter. Here substituting the SI unit of the quantities, physical quantities, then we will get finally rho is equal to ohm meter. Here the resistivity is the characteristic property of every conductor. If the resistivity of a conductor is more, then it will offer more resistance. If the resistivity is less, then it offers less resistance. The resistance of a conductor also depends upon the nature of material as taken as the conductor. Let us suppose we have taken a copper wire and an aluminum wire of same thickness. Here we can find the resistance offered by copper wire and an aluminum wire, both will be different. From this we can say that The resistance of a conductor depends upon the nature of material, and the resistance also depends upon with the different temperature. If the temperature between the two conductors are different, then also the resistance will be differed. So at a particular temperature, the resistance offered by a conductor will be depend upon the nature of material, area of cross section and length of the conductor. So these are the three important factors on which the resistance of the conductor depends. Now memorize these two formulas, that is R is equal to rho LA and rho is equal to RA by L. These equations will help you to solve numerical problems based on resistance. So far we have discussed about the various factors on which the resistance of a conductor depends. Let us now understand the resistance of a system of resistors. Before that, we should know what is resistor. Resistors are the components that are used in an electric circuit which offers resistance. For example, in a circuit we may have a bulb, fan or any other components we will be attaching, right? And these components exerts or offers resistance in a circuit. So we can say that bulb is a resistor which offers resistance, fan is a resistor which offers resistance. This way the components that are used in a circuit which offers resistance are called resistors, and these resistors could be combined in different ways. So there are two ways by which the electrical components or the resistors could be combined in an electric circuit. The resistors in a circuit could be combined in two ways. One is resistors in series and the second one is the resistors in parallel. Now let us learn how the resistors are combined in a series. Before that, you should know the symbol of resistor. We have already in the last episode I have asked you to remember and by heart the symbols, right? So this is the symbol of the resistor. Now let us see how they are combined in series. Now see the circuit diagram here, three resistors are combined in series. Now from the circuit diagram it is clear that in order to combine the resistors serially, they are arranged linearly one after another, right? So such kind of arrangement of resistors in a circuit is known as serial arrangement or resistors in series. Resistors can also be combined in parallel. Now see the circuit diagram here, the parallel arrangement of resistors. You can see very well in the circuit diagram that we have used three resistors and all the resistors are in parallel combination. Since all the resistors are parallel to each other, right, one after another, one below another they are arranged. Such an arrangement of combination of resistors in a circuit is known as parallel combination. Dear students, in an electric circuit we may have two or more than two resistors. Altogether, combining all the resistance offered by the electric circuit is said to be the total resistance or equivalent resistance. How to find the total or the equivalent resistance in case of serial arrangement of resistors and parallel arrangement of resistors, about that we will see. Firstly, we will see how the total resistance could be found out in a serial combination of resistors. We know the symbol of resistor, right? This is the symbol of resistor, usually represented by the letter R. Now let us see how the resistors are combined in series. To combine the resistors in series, we have to put all the resistors linearly. For example, this is the first resistor, then the second resistor and the third resistor. This will be our resistor 1, R1, this is R2 and this one will be our R3, right? Now we include in our circuit. So this is our circuit, here applied potential difference, right? Now here I am including a key. To know the current flowing in a circuit, we will include an ammeter. So this is our positive terminal and this is our negative terminal. Here it is the direction of flow of electric current. In the circuit, the amount of current flowing throughout the circuit remains same. Although we have three resistors connected in series, in case of serial combination, the total current in the circuit remains constant. However, the potential difference across each resistor changes. If we connect a voltmeter across R1, then that will be the potential difference V1. If we connect voltmeter across R2, that will give you the potential difference 2, that is V2. Similarly, for resistor 3 we will get, if we connect a voltmeter across AB, then that will give you the total potential difference between the points A and B. Here the total potential difference is equal to the sum of individual potential difference across the point A and B, which means the sum of each potential difference across each individual resistor will give you the total potential difference. So total potential difference can be written as V is equal to V1 plus V2 plus V3. Now in this circuit, instead of using 3 resistors separately, we can have a single resistor called equivalent resistor with resistance R. So by using Ohm's law, V is the total potential difference and I is the current which remains constant in serial combination, and R is the equivalent resistance. Now by applying Ohm's law on each resistor, then we will get V1 is equal to I, which is constant. Now for R2 we can write it as V2 is equal to I R2, and similarly V3 is equal to I R3. V is equal to IR. So IR can be written as IR is equal to V1. The value of V1 will be IR1 plus IR2 plus IR3, right? Now taking common, we will get IR is equal to I as common, R1 plus R2 plus R3. Here I gets cancelled, so here we will get R is equal to R1 plus R2 plus R3. Now this is the total resistance or equivalent resistance when resistors are connected in series. So I believe how the total resistance could be found out in a serial combination. So it is Rs is equal to R1 plus R2 plus R3 and so on. Let us now understand how the total resistance could be found out in a parallel combination. So here I am making the first resistor, here I am having the second resistor, here I am having the third resistor. Here we write it R1, this will be our R2 and this will be our R3, right? In a circuit containing the parallel combination of resistors, it is observed that the total current is equal to the sum of the currents through each branch of the combination. Let us find out how to find the total resistance in a system of resistors in parallel combination. Now from this we know that I is equal to I1 plus I2 plus I3, and we know that I is equal to V by R. Here R is the resistors in parallel, we write it Rp. By applying Ohm's law across each resistor, then we will get I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. So we know that I is equal to the sum of all the currents I1 plus I2 plus I3, and I is equal to V by Rp. So we can write V by Rp is equal to I1. The value of I1 is V by R1 plus V by R2 plus V by R3. So by taking common, we will get V by Rp is equal to V as common. So we will get 1 by R1 plus 1 by R2 plus 1 by R3. So here V gets cancelled. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Hope you understood the parallel combination. So whenever we talk about parallel combination, it is just 1 by Rp. Here P indicates parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Dear students, while finding the total resistance in serial combination, we have seen that current remains constant throughout the circuit, whereas potential difference changes across each resistor. Similarly, in case of parallel combination, we have seen that potential difference is constant throughout the circuit, whereas the current changes across each resistor. Why such kind of changes we see in serial and parallel combination? Answer for this we will see in another video. So that's all we have for today. If you like this video, then hit the like button. Still, if you have any doubt, then you can mention it under the comment section. So see you all on another day with a new topic. Till then, take good care of yourself. Bye.